Good morning, one and all. Today our topic is Pelton turbine. In turbines, one of the important type of turbine is based on the working principle, that is impulse turbine. So in impulse turbine, only one of the example is there, that is Pelton wheel or Pelton turbine. We may call it as Pelton wheel or Pelton turbine. So it is helpful. It is one of the machinery which is helpful in generation of the electrical power. So today we are going to understand this topic. These are some of the web references which are giving more knowledge on the Pelton turbine or Pelton wheel. So coming to the Pelton turbine, this is the skeleton structure of the Pelton turbine. In these, casing, nozzle, penstock, movement of spear rod, spear, deflector, jet of water, shaft, split buckets, runner, braking jet, brake nozzle. These are all the components which are in Pelton wheel or Pelton turbine. So coming to the Pelton wheel or Pelton turbine, this is the one of the best example for impulse turbine. So based on the working principle, we have two different types of turbines. That one is impulse turbine, other one is reaction turbine. Impulse turbine, Pelton wheel is the one of the best example for impulse turbine. Coming to this Pelton wheel or Pelton turbine, these are the components which we have in this. So based on this is the shaft we have, and it is going to rotate. So in this, these are the splitting of the buckets. These are the number of buckets which are present in this turbine. So this is the casing which is present to prevent the accidents, any sudden things which happened, and to protect the all the setup and all the components in the Pelton wheel. It is the helpful. So this is the jet of water which is coming from the penstock, and from these big penstocks, nozzle is fixed. From this nozzle, how much at the time of design and at the time of analysis we are going to determine how much of the jet of water is enter into into the buckets. So these are all comes under in these at the time of the design we are going to design how much jet of water which is required, and based on this movement, this spear rod and this spear are going to fix that how much movement and how much the jet of water which is required for filling the bucket. So these are the components. It is there, and this is nozzle, and these are the deflectors, and these are runner, shaft, jet of water. All these are the components which are present in the Pelton turbine. So this is the one of the example for the impulse turbine. Impulse turbine's example is Pelton wheel. So like this, these are the buckets. We may understand. So like this, whenever the jet of water enter into the buckets, this is going to rotate. This is going to rotate, and the jet of water fills this. Next one, it is going to rotate. Next, this is the fixed one. Whenever the nozzle and penstock they are fixed, and this moving rod is helpful the jet of water for filling this bucket. For filling the buckets, this moving rod is helpful. So like this, we understand like this. This is the nozzle. So this is the jet of water which is going to fill, and this is the rotating one. The Pelton wheel is going to rotate. All the buckets are present. So one by one, this is the constant one. This is the fixed one, and these are going to rotate. So one by one, they are going to into this jet of water into the buckets. We've done the thing. So parts of the Pelton turbine: nozzle with flow regulating arrangement. This flow regulating arrangement which is helpful how much the jet of water is required for the designed turbine bucket. So in that bucket at this vane, how much jet of water is going to carried, how much for each and every time, based on the number of buckets, how many number of buckets are there. This is also at the time of design we are understand. So this runner with split of buckets, the casing is which is protecting, and this braking nozzle also there. These are the parts of the Pelton turbine. In this Pelton turbine, this is the basic working principle. When a high speed water jet inducted through a nozzle hits bucket of Pelton wheel, it indicates a impulsive force. So impulsive force is the working principle. This is the one of the key factor for working principle of Pelton turbine. So this force makes the turbine rotate. The rotating shafts runs a generator and produces electricity. So Pelton turbine transfers kinetic energy of the water jet to the rotational energy. Pelton turbine transfer kinetic energy of water jet to rotational energy. So this is the complete setup of the Pelton turbine for a power plant. So this is the setup. This is the tail race of the. So here it is the dam. From this is the head race, and this is the reservoir. This total from tail race to head race, the in between, this is the gross head. Whatever the friction losses it is there, from here to here, that is the net head. So these are the frictional losses. Friction losses. From where gross head is equal to net head plus frictional losses. So net head H is net head, Hg is the gross head, Hf is equal to frictional losses by frictional losses. So like this we are going to divide these, and from the reservoir in that particular dam, the overall head raise to the reservoir, that is the gross head raise to tail raise, that is nothing but the gross head. So we are considering the net head from reducing the frictional losses through gross head. So this is the surge tank in this, from this tunnel. So penstock and nozzle, all the moving rod is present here. Excess, it is depends how much water is going to enter. Not the flow is going to regulate because of the how much water is required for the filling of this bucket is designed. So from that, whatever the excess is there, it is going to stay in this surge. Sometimes it may require, if the flow is less, so reservoir is half empty. So in those some of the situations, the surge tank, from this surge tank, we may generate the water, the jet of water we may create from this surge tank also. So this is the overall layout of the hydraulic power plant with Pelton wheel. So coming to the reaction turbine, the pressure of liquid changes while it flows through the rotor of the machine. The change in fluid velocity and reduction in its pressure causes a reaction on the turbine blades. So for example, these reaction turbine are Francis and Kaplan turbines are the best example for reaction turbine. In this, pressure liquid changes while it flows through the rotor of the machine. Coming to the impulse turbine, the pressure liquid does not changes in the situation. So like this, we are understanding this Pelton wheel and reaction turbines. In this, coming to the Francis turbine, these are the components which we have. Those are penstocks. It is a large size pipe which conveys water from the upstream to the dam or reservoir, whatever it, to the turbine runner. This is the water penstock. So this is the spiral casing, and this is the runner, and this is the guide wheel for Francis turbine. In this penstock, spiral casing, guide wheels or guide vans are there as a components. In this, it is a large size pipe which conveys water from upstream to the reservoir to the turbine runner. Coming to the spiral casing, it constitutes a closed passage whose cross-sectional area gradually decreases along the direction of the flow. Along the direction of the flow, the cross-sectional area is going to decrease. So area is maximum at inlet, nearly zero at the outlet. This area is maximum at inlet and zero at outlet. This spiral casing is like this. This is going to reduce. If we understand this spiral casing at entry of this, it is used. Coming to this, it is going to reduce. This overall spiral casing we may understand in the figure. In this figure we may understand. So coming to the guide wheel, these vents direct the water on the runner at an angle appropriate to the design. The motion of them is given by means of a hand wheel or by governor. So like these are the components. All these components is in the working process of Francis turbine. This governing mechanism, it changes the position of the vanes to affect a variation in water flow rate and the load conditions on the turbine change. Coming to the runner, the driving force on the runner is both due to impulse and reaction effect. Coming to the draft tube, it is gradually expanding tube. It is a gradually expanding tube. Draft tube is gradually expanding tube like this. Otherwise, like this, gradually extending, gradually extending tube with which discharges water passing through a runner to tail race. So these are all the components in our Pelton turbine. Francis turbine. These are the components which are all present in Francis turbine. Penstock, spiral casing, guide vans, governing mechanism, runner, draft tube. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.